Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is minimum time difference. So the problem statement goes like this: you will be given a list of 24-hour clock times or points time in the format of this particular format R and minute format. Okay, and then you have to return the minimum minutes between different any minimum minutes difference between any two points given in this points of time given in this list. Okay, so this times point list will be given to you, which will be representing 24-hour clock times time points in this particular format. Okay, and you have to return the minimum minute difference between any two points in the given list. Okay, so see this if we add just 1 minute to this particular time, then we will be reaching this time. Okay, so only 1 minute difference was there, and between these two points, since they were representing the same time, so 0 minute difference was there. Okay, and before thinking of an approach, let's have a look at the constraints also. So according to the constraints, the length of this points time points list will be of order 10 raised to power 4. Okay, 2 into 10 raised to power 4 basically, and each entry is in the format of hour and minutes, this particular format. Okay, so let's think of an approach how we can solve this particular problem. So the very first approach that came to my mind is that we should be sorting the time points. Okay, so if you sort the time points, then the minimum difference between any between adjacent pairs will be the one that we will be looking for. So what I mean to say is, so if you first of all you might be asking how the sorting will be done. So first of all, the preference will be given to the R if two entries are having the same R, and this will be in ascending order. Okay, you can change the order also to descending, but I have taken here ascending order. Okay, so then uh, preference will be given to minutes if the R's of a two entries are same. Okay, so this will also be in ascending order. Okay, so for example, this particular thing is given to you. Okay, so this is the list that is given to you. If you do the sorting, then first of all R's will be seen. So this entry should be your first entry. Okay, and after that the second entry should be this particular one. Okay, and if there was a situations that this particular entry was also there, so in that particular case you would have done something like this. So instead of this being the second entry, the second entry would have been 0035. So see, in these two particular entries the hours were same, so the preference was given to then minutes. According the sorting was done according to the minutes, and the one with the lesser minutes came first, and then comes the one with the more minutes. Okay, so then the third entry will be 2359. Okay, so I hope you are able to understand how sorting will be done. So why we are doing this sorting is because it help us to find the minimum difference, because if you sort them in ascending order, then see what is the minimum different, you know what is the point to which a particular, let's say this is the time entry that you are searching for, and you are searching for the time entry which is at the minimum distance from this particular time entry. Okay, so either it will be its left or right neighbor. Okay, either it will be its left neighbor or right neighbor in the sorted order. Okay, that's why we are doing the sorting. Okay, otherwise if you want to check its possibility with every entry in the times list or times point list that is given to you, then you have to do a quadratic time complexity. Okay, and because of the constraints, this thing will not be allowed. See, 2 into 10 raised to power 4. So, and there is a limit also of the number of operations allowed, which is that the number of operations that your program is requiring to solve a particular problem should be well within the limits of 10 raised to power 8 operations. This is the ops limit, you can say. If the operations that are required by your solution are well within this limit and less than this limit, so your solution will be accepted. Otherwise you might get a time limit exceeded error. So in order to avoid that kind of scenario, we decided to sort the time points so that for each of the point in the time points list, only two checks should be done, one with its left neighbor and one with its right neighbor. Okay, and other than that we are just fine, so we need not to do any check. Okay, so kind of this was the intuition that I uh, that I that came to me after reading this particular problem statement. Okay, and but there is a little uh, then there comes then this problem becomes the implementation problem. Then you have to just implement your idea, and we will be seeing in a bit how we have implemented this approach. Okay, and then while seeing the implementation we will be discussing edge case also. Okay, basically I will tell you graphically or with the help of a diagram. So consider a situation that you are at a particular time, let's say 23, which represents 11 p.m. Okay, and this is today. Okay, so you are also given a point of time which is representing tomorrow. Okay, basically here you do not know whether this uh, you know particular time is of next day or today, so you want to consider both of the situations. So this time might be of next day or this time might be of today. Okay, so because you see the circular nature of clock will come into play here. So if there is 11 at this particular time, okay, and let's say at a certain time you are also given another entry which is representing, let's say 3 a.m. Okay, so if you want to consider this particular difference from here to here, this difference is obviously larger than this particular difference. Okay, the white one. So in order to get the minimum minutes between two time points, we should be considering this kind of scenario also. Okay, and this scenario will only be considered between 2 points, and those 2 points will be the first and the last points in the sorted time points list. Okay, so between these 2 points. Okay, so if you consider between these 2 points, this will be a 1 minute gap only. Okay, otherwise if you consider only differences, these kind of differences, so see there is 35 minutes gap. Okay, and from 12:35 to 11 uh 59 p.m. So this is am basically, 12:35 am to 11 p.m. There is a huge gap as compared to only 1 minute gap between the first and the last entry. Okay, so that's why for the first and last entries in the list, sorted list basically, you will be considering this circular nature. Okay, so that we will see how we have done in the implementation. Now without further delay, let's go to the implementation part. And for that I will be taking the code to the board. And now I think it should be fine. And let's remove the toolbar. Okay, and let's begin discussing. So as I talked about that, we need to sort the time points in sorted order. Okay, in order to avoid that quadratic time complexity. So we will be doing something like this. Each time point will be stored as in an integer form, basically an array of size 2, two entries. The first entry will represent the hours and the second entry will represent the minutes. So 0th index will represent hour and the first index will represent minutes. Okay, and as far as this string nature of time points being under consideration, so what we will be doing is we will be parsing this into the integers. Okay, so if you pass this particular string, it will be looking something like this in the array. Okay, so this will be your hour and this will be your minute. Okay, so that's what we are doing indeed here, parse time. So this what, let's see what does this parse time function does. First of all, this parse time splits the given string into two entries of the string. So basically this will be available to you. Okay, then you just call a parseInt function. In Java it's available. Okay, like this. uh, so this will return you the integer equivalent of the corresponding string, and once you are having that, you will simply return your integer array of size 2. Okay, and then you will be adding it into the uh, time points. Okay, which is by the way an integer array. Okay, so this was the integer array, so this will be the array on which sorting will be applied now. Okay, so the first preference was given to the hours. If the hours are same, then the preference will be given to the minutes. Okay, otherwise if hours are not same, then obviously we will sort according to the ascending order of hours. Okay, so once sorting is done, then the task of finding the difference between adjacent pairs comes in. So you will be doing that. So this is previous time, just one previous. So if you are at this particular entry, so you will just see for one previous. Okay, this particular one. So this is the previous time. Okay, and this will be the current time. Okay, and then you will simply find the difference. Okay, let's see how this calculate function is being implemented. For that we are just converting the whole thing into the minutes. Okay, so multiplying hours by 60 and then adding minutes. Okay, 1 hour is equal to 60 minutes, that's why. So once you have done that, converted both previous and current times into minutes, then finding the difference will become really easy in terms of minutes. Okay. So then you will be having your current diff value or the current difference. Then you will update your minimum difference. Okay. So once this is out of the way, you will consider a special case that we have just discussed between this 11 p.m. and 3 a.m. scenario. Okay. So in that particular case and in this particular array also this applies, as we have already talked about. So you will be basically to do this, you what you will be doing is, for the first entry to consider it in the next day, you have also already considered the first entry to be of the same day as today. Okay. So let's say this is of next day entry. To convert it into a next day entry, you will be adding 24 hours to it. Okay. So in order to symbolize the circular nature of time or this clock basically. Okay. 24 hours format to be more specific. Okay. So once you have done that, then you will just find the difference as you do in usual time calculations. Okay. And since this will be your uh, lesser time or the, you can say, previous time, so you will obviously be finding the difference between the two. And once you have the difference, then you will again try to update your minimum difference with this particular edge case that you have considered. Okay. And then simply return your minimum difference. So this is the whole logic. Okay. And basically the very first thing that you should be thinking of after seeing this kind of problem is how you will be reducing, how you will be getting your solution accepted in terms of complexity. So since checking making pair of every time point with every other point in the array or the time list would result into quadratic time, that's why we did the sorting here. Okay. And rest all the things are implementation other than taking care of this particular edge case, you can say. Okay. Or special case. So this is the whole approach. And if we talk about time complexity, wise, see, since we are doing the sorting, and let's say this times points array is of size n, then order of n into log of n will be required for sorting, and other time complexities for other kind of operations will be lesser than that, so we are ignoring them. And space complexity wise, since we are using this time points array, and so the overall time complexity can be approximated to order of n. Okay. Because see, 2 into size is what you are using as auxiliary space here in order to achieve that sorting. Okay. So yeah, that's the whole complexity analysis and the approach. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. I really hope this solution walkthrough added some value to your journey of honing your DSA skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.